Yeah, what's going on, my friends? Let's carry on. So, in this session over here, we're gonna be talking about the greedy solution as mentioned in the previous video. So, first of all, let me just get rid of this code. We're gonna write it from scratch just so everybody can follow along. So, I'm just gonna cut this out for now. I'm just gonna paste it here. I'm just gonna comment it out. So the first thing that we're getting is an array. So what we do with this array, it's an array of objects. So these objects, discrete objects, are objects which you cannot really divide. And then what we do with these objects, we want to pick them up in an order such that they will yield the maximum value. So what we need for that, we need to sort them out in case you haven't forgotten how these algorithms work, but you have forgotten, just quickly remind yourself on Google how this algorithm works. So, but then I just want to keep this thing short and straight to the point because I just want to cut to the chase of how the dynamic solutions actually work. So the greedy ones, the first thing we're gonna do, we're just gonna sort these arrays. We're gonna sort them. So basically the way I expect this array is gonna be an array of objects. This object is gonna have a value and a weight. So imagine you're a thief, you break into a house and then the first thing that you pick up is a fridge. So fridge is of high value but it's very heavy. And so you might not, so that is a factor, you might not pick it up simply because of that, but you know, a watch might be of value, but you know, it can fit in your pocket or something like that. So that is the concept we are going with. So we're going to sort them by by the ratio of the value to weight, and then we simply gonna pick up the item of the highest ratio as long as it fits into our knapsack capacity. And that, with that being said, let's get some code of the way. So this is going to be array sorted. So these we're going to sort them the way that the sort building JavaScript sort works. It takes a function. You can do something like this, and you can write it like that. But I prefer other functions, so I'm just gonna write this as an array function. But before I do that, this thing takes two arguments. So the first argument it takes is item one, item two, and then inside the function you have to define the criteria in which you order these two items. And this is functions are basically going to be called on all of these items to sort them. So this is going to be item one, and this is going to be item two. And then we're going to do some computation in here. What we want to do, we just want to return the ratio of or comparison of the ratio of the two items. So depending in what order we want to sort them. If we want to sort them in ascending order, then we'll have to say A minus B. And if we want to sort them in descending order, you have to say B minus A. And that is what we're going to do here. So we're going to say item 2 divided by item 2 dot value divided by item 2 dot weight, right? This is you want the difference of its value, and here is weight. This is all you want. And basically what you see this is it's gonna then sort them out for us, and you know, you return the comparison of this. And like I said, this is ugly notation. I prefer the other function, so I'm going to change this to other function and write it like that, and I can basically throw that on one line, and just like that. And then because I'm actually not even doing anything other than just returning, I'm not even going to have the return statement. I'm going to get rid of it, and I'm just going to throw this inside of just brackets, and that will return this value. And once I have this sorted array, then have to loop through these items. So I'm gonna say the length of these const length is equals to array dot length And then I just want to say for let I is equals to, I'm going to start from 0, all the way up to the length of these items. Alright, so I'm going to come here. So inside of these, I want to check the item in hand. So the item in hand is the item that I have during these instance of iteration. Actually, let me just use this one here. But they really should be the same length because it's the same array just sorted. And then once I have this, I will simply say these item I. So there's current item. Let me just call this current item. No, let me just say item in hand. Yeah, I'm gonna call it item in hand because that's what I think makes a little bit more sense. So I'm gonna say sorted. This will be at index I. So what I want to do with this item, I want to check if its weight, or I want to check if this item can fit in the capacity of what I already have. So to do that, I want to say if item at hand, if item at hand dot weight plus the current weight of the sack. Probably need to define there somewhere out of this. I'm going to say let I'm going to call it sack is equals to 0. So I want to say sack plus this must be less than this max weight, or less than or equal to, because we can take that value. So if these items weight plus the weight of what I already have in the sack is less than the maximum, then I throw it into the sack. Okay, so to throw it into the sack, I simply say sack is equals to plus minus these items weight, not the items weight but the items value. So I want to say item in hand value, and then I increment the weight. And then I increment the weight. So actually I need two variables because I need to keep track of the whole sack and I need to keep track of the weight of the, let me say sack value, and then say sack weight. Okay, so when I'm starting, the sack doesn't have any value and doesn't have a weight. So I'm going to say if these weight is less than that, then sack value is equals to these items value plus, and then sack weight must also increment. And then to increment that, you simply slap this in, and that's pretty much it. Then at the end of this, we simply return this value. Right? And then as you can see, this approach should then yield our solution. Let's see that this, for the same input, it's still gonna yield me the same arguments. Actually, to do that, let me just put a breakpoint here. Which one is it? It's this one here. Oh, this is the greedy one. Yeah, so it's this one. I just want to put a breakpoint here. Cool, so we have that. Let's just step over. Cool, so this algorithm is still correct. As you can see, it's now computing all the others. It's still correct and it's still running at the same efficiency as the previous one. So to recap, actually let's compare these two codes, because this is the code that I initially had. If you take a look here, the only difference between these and what I originally had is that the previous one is, as you can see, it was sorting them in the reverse order. And then that's why when we had to count, we still had to start to count from the length going all the way to 0. And then what else? This one here, sort them in the top. So the highest item of the highest value would be at index 0. That's why we're starting at index 0 here and going to this length. And yeah, other than that, these things are identical. All right. So that's it. That's pretty much it. Then thank you guys for tuning in. I will see you guys in the next session where we will be discussing the dynamic solution approach. So basically, there's the very minimal dynamic approach. I'm going to take you through how exactly this solution come about, and then hopefully you guys can learn one or two things from there. But otherwise, thanks for tuning in, and then I'll see you guys in the next one. Ciao. Have a good one.